Hey guys, welcome to Mr. Nelson's chemistry class. Today we're going to do again another video that deals with molar mass, this time practice sheet number 2, problem number 2. Now, as always, we've been trying to do the nomenclature for these right here. We're not going to worry about the nomenclature on this one. And the reason is because it doesn't fit the boundaries of what we normally would do as far as something that is binary, type 1, polyatomic, or type 3, type 1 or 2 binary or polyatomic, or type 3, or an acid. So it's a little bit different, but it is a compound that has carbon, chlorine, and fluorine in it. So what I already have set up here is how many we have of each one. So if you haven't figured it out, we have one carbon. There's carbon. Okay, we know by the capital letters, we have 1, 2, 3 capital letters, 3 elements. We use the subscript that's right here. Since there's no subscript, we put a 1 in there. So we're going to put a 1. And then chlorine, I have 2 chlorine because of the subscript. I'm going to put that there. And then we have fluorine, which we have 2, and we're going to put, and that 2 is right there, right there. Now we got to, when we figure out molar mass, we have to figure out what is the molar mass of each element in the compound and how many of those elements do we have. So we put down how many we have of each one, but we have to figure out the molar mass of each one, which is also equal to the atomic weight. So how to figure that out? We go to our periodic table. So we had carbon, which is 12, chlorine, which is 35, and fluorine, which is 19. Had a hard time remembering that fluorine. So we have 12 here, 35, and 19. Let's go back and double check those again. So we have carbon 12, fluorine 19, chlorine 35. Again, it's the larger number in the box is the atomic weight, which is also the molar mass for that particular element, unless it's diatomic, and then it would be double that because we have to have 2. So let's go back to this. So we're going to be pretty easy on this one. So 1 times 12 is 12. This one's not too bad either. 35 times 2, we just double 35. So that's going to be 70. And then 2 times 19, again, that would be like saying 20 times 2 minus 2. So that's going to be 40 minus 2, which is 38. Now we're going to go ahead and figure out the molar mass. So the molar mass equals all of these added up. And we could go ahead and do it, and I could say, okay, 8 plus 2 is 10. We're going to hang that over there. This is 7 plus 3 is 10, 11, 12. So it should be 120. Okay, so let's double check it. I'm always about the double check. So we're going to go ahead and put 12 plus 70 plus 38 equals 120. We should be right. Now that's going to be in grams. Now it's grams of what? And this is where you really got to make sure that you pay attention and show your work, is that it's going to be of this right here. So we're going to copy this, and we're just going to come down here and paste it right there. Now that's the easiest thing about doing it digitally, is that you can cut and paste pretty easy. So we're going to go ahead and highlight that. And there's our answer. The molar mass of this compound is 120 grams. Hopefully it helped you out. And as always, Nelson out.